Algebra 2, Common Core, solving radical equations. So you solve radical equations the same way you solve all other equations. You're always doing the opposite operation to remove terms away from your variables. So if you don't need to write this down, just watch for a second. If you have like x plus and you're trying to solve, you minus. If you have x minus, you'll add 5 on both sides. You know, if you have an addition happening to x, you do the opposite subtraction. If you have a subtraction happening to x, you do the opposite, you add. If I have 2 times x, I'm going to divide. If I have x divided by 2, I'm going to multiply. So adding and subtracting are opposite operations. Multiplying, dividing are opposite operations. Well, the same thing kind of happens with squaring and square root. Like if I have x squared equals something, I'm going to do the square root. Well, if I have the square root, I'm going to square to get rid of that. Squaring and square root undo each other. And so that's what we're going to see here, is I got to do the opposite operation of all this stuff to get this x alone. The square root of 4x here, I need to deal with that last. We always got to deal with the things around it first. So first thing I can do is this minus 1. I can get that to the other side. I'm going to add 1 to both sides. So add 1 there. So 2 times the square root of 4x equals 8. And then this times 2, and I know it's times 2 because it's attached to the front of it. There's no plus or minus between. It's a coefficient of the radical. That's being multiplied. So I want to just simply divide that away. So divide that away. And I'm left with the square root of 4x equals 4. And so now I've isolated the radical, and that's always step 1. Isolate the radical. And then square both sides to get rid of that radical. And squaring a square root, you get just what's inside that radical. So square root of 4x squared is 4x, and the square root of 4 over here is 16. Divide x equals 4. It's important with radical equations that you check your answer. Plug it into the original, because it's possible to get what we call extraneous solutions. Sometimes you have to cross out your answer and write the word reject. But not yet. Let's see if it works. But that does happen sometimes. So if I plug in a 4 here, 4 times 4 is 16. The square root of 16 is 4. Times 2 is 8. Minus 1 is 7. It checks out just fine. So x does equal 4. All right, this one, I see the radical is already isolated, so I could jump right to squaring both sides. You see the difference between, like, this minus 1 was outside the radical, this plus 1 is inside of it. If you have numbers outside the radical, like we did here, the 2 and the minus 1, you got to deal with them first. And once you have just things in the radical, then you square both sides. 6x plus 1 equals 25. 6x equals 24. So, I squared both sides, and what I got over here was just the term left inside. I square the 5, 25. Then I minus 1, and now I'm going to divide and get x equals 4 again. Let me check it this time. 6 times 4 is 24, plus 1 is 25. Square root of 25 is 4. Checks out. Let's keep going. A couple more examples. All right, this one I need to, first I see I have a negative 2, a minus 2 inside the radical, but I have plus 3 that's not inside. So I'm going to move that first. I'm going to subtract 3 on both sides. The square root of x minus 2 equals negative 3. Now that the only thing on the left side is a radical, that's when I square both sides. Squaring a square root, I get the expression inside. Negative 3 times negative 3 is positive 9. We know the negative square positive. Add 2, I get x equals 11. Let me check it. So plug in 11 here. 11 minus 2 is 9. The square root of 9 is 3. Plus 3, 3 plus 3 is 6. That does not equal 0. This does not work. I cross it out and I write the word reject, because it did not work out. And right around here is when I kind of had a hint about that. If you ever get a point where you have a square root equals a negative number, that's not going to work out. Square roots can equal negative. The square root of x cannot equal a negative number. A square root of an expression cannot equal a negative. And that's just kind of a restriction we need to always be aware of. And you can just check your answer and it won't work, but if you ever get to the point where you have a square root equal to a negative, that's a big hint that is probably going to happen. So you have to reject your answer. You still have to find out what x is, but you need to reject it at the end. So be careful with that. All right, this one over here, the radical is alone, but this is not a square root. When you have this little 3 there, that means it's a cubed root. So it's still a radical. I still need to get the radical alone, which we have over here, but I'm not going to square both sides to undo a cubed root. I'm going to cube both sides to undo a cubed root. And so when I do the cubed root cubed, that undoes itself, and I'm left with the expression inside, 2x plus 3. And 3 cubed, well, 3 times 3 times 3 is 27. Minus 3, and we're going to get 24, and x equals 12. And we got to check that. 2 times 12, 24. Plus 3 is 27. The cubed root of 27 is 3, so that does check out. See, a square root can equal a negative. A cubed root can. That didn't come up here, but cubed roots can equal negative. Much in the same way where a negative square is positive, but a negative with an odd exponent like cubed does stay negative. So this is an important restriction to watch out for. But occasionally we'll get extraneous solutions like this. We have to reject answers. One more example. All right, this is a square root this time. The radical is isolated on the left side, so I don't need to move anything over before squaring both sides. But what makes this example a little bit more challenging is not what's on the left. That's going to give you 2x plus 14. But what's on the right? This is a binomial squared. A binomial squared. It's an expression squared. And when you square a term, you have to multiply it by itself. Squaring something like 3 or negative 3 or 4 here or 5 here, that's pretty easy. We know those numbers. We know 5 squared is 25. But do you know what x plus 3 squared is? It's not x squared plus 9. X plus 3 times x plus 3 requires distribution. If you multiply it out, it's 2 by 2. And so you end up with x squared, and then a 3x, another 3x, and a 9. And the middle terms combine to be x squared plus 6x plus 9. So you get a trinomial. And this concept of a binomial square, this tends to come up a lot throughout this course. So you really need to be aware of that when you see an expression being squared. Times it by itself. If you're good, you can kind of do this in your head. It works out to be the first term squared times each other, but doubled is how you get the 6x, and then times the second piece squared. But that comes up a lot, so you need to be prepared for that. But it's very common for students to think it's just x squared plus 9. It's not. It's x squared plus 6x plus 9. It's always going to be a trinomial. All right, at this point, I see an x squared, but I have x to the first also, and so that's your big hint that this needs to be factored. So you're going to set it equal to 0 and factor. So I'm going to minus 2x, making that a 4x, and minus 14, making it a negative 5. And then I get x, let's see, plus 5 and negative 1. Those are the numbers I multiply to negative 5 and add to 4. And when I solve them both, I get x equals negative 5, and I get x equals positive 1. They may both work, or they may not both work. And I want to check them out. So first, let me check x equals negative 5. If I plug negative 5 in here, that would be negative 10 plus 14 is 4. So that would give me the square root of 4 equals a negative 5 here. Negative 5 plus 2 is negative 2. And no, a square root cannot equal a negative. That gets rejected. How about x equals 1? If I plug in a 1 here, 2 times 1 is 2, plus 14 is square root of 16. And I plug in a 1 here. 1 plus 3 is 4. Yes, that does work. So sometimes they both will work. Sometimes they'll both reject. Sometimes it's one of each. But you have to be careful. You have to check them both. And always watch out for those extraneous solutions. So that's radical equations. Sometimes you got to move things away from the radical before you square both sides, like we did in this case. Sometimes you have to cube both sides because the radical is a cubed root. And sometimes the squaring or cubing of both sides might be an expression, so you have to be careful with your algebra, and maybe some light factoring could be involved in that process as well. All right, so that's radical equations. See ya.